2010 Grade 10 Galois Math Contest. Emily's old shower head used 18 liters of water per minute. She installs a new shower head that uses 13 liters per minute. When Emily takes a bath, she uses 260 liters of water. Using the new shower head, what length of shower in minutes uses 260 liters of water? So I guess it's just straightforward. 260 liters divided by 13 liters per minute. And when you do that, you get 20 minutes. How much less water is used for a 10-minute shower with the new shower head than with the old shower head? So I guess you make a comparison. The old one was 18 liters per minute, and you are going to use that for 10 minutes, so that's going to be 180 liters. The new one is 13 liters per minute, and again, if you use it for 10 minutes, that's going to be 130 liters. So the difference is 50 liters, and that's basically how much less water she's going to be using with the new shower head in comparison to the old one. See, Emily is charged 8 cents per 100 liter of water per 100 liter. That's very important. Using the new shower head instead of the old one saves water, and so Emily saves money. How much money does Emily save in water costs for a 15-minute shower? All right, so as before, it's in the old one, 18 liters per minute times a 15-minute shower, and that's going to be 270 liters. Now, it's 8 cents per 100. So first we have to divide this by 100 and then times by 8 cents. And when you do, you get 21.6 cents, I believe. Yeah. Okay, so the same thing now, same type of calculation for the new shower head. It would be 13 liters per minute times 15 minutes. And that is 195. But then, of course, you've got to take this 195 and divide by 100 and then multiply by the 8 cents. And when you do, you get 15.6 cents. So the difference is 6 cents. So 6 cents is how much she saves in water costs for a 15-minute shower with the new shower head. Part D. How many minutes of showering using the new shower head will it take Emily to have saved $30? All right, so based on part C, it looks like every 15 minutes she saves 6 cents, right? That's pretty much what we calculated. So $30, if you do a little calculation on the side, $30 divided by 6 cents is basically 30 divided by 0.06, which is 500. So she would have to have 500 of those 15-minute showers, I guess, or 500 times 15 minutes. So that is going to be 7,500 minutes of shower time that would result in a cost saving of $30. QABO is constructed as shown. Determine the area. All right, so in this diagram, we have this nice little graph, and we are told to figure out the area. And the first thing I'm going to do is I'm going to cut it into two segments. So one being a rectangle and another segment being a triangle. And let's label this. So this looks like to me 2, I believe. And then therefore this top to bottom is 12. And then just from here to here is 12 minus 2, so that's 10. And then this is 2. So the area of QABO is going to be 2 times 12, which is the rectangular part, and then 1/2 base times height for the triangle part, where the base is 10 and the height is 12. So that is 24 plus 60, so that's 84. Part B. Point C, which is 0p, lies on the y-axis between Q and O. Determine an expression for the area of triangle COB. Triangle COB. All right, COB. So from here to here is 12, and from here to here is P. So I guess it's just a simple basic 1/2 base times height. I don't think there's anything more to this than that. So that's just 6p. Yeah, all right. Moving right along, determine an expression for the area of QCA. QCA, where's that? QCA? Up here. Okay, so we got this little guy here, QCA. So this is 2, and this distance here is 12 minus p. So triangle QCA would be 1/2 base times height, which is 2 for the base and 12 minus p for the height. So that is 12 minus p. Yeah. And then finally D. If the area of ABC is 27, determine the value of P. So where's ABC? ABC. Okay, ABC is this guy right here. So that whole thing. Okay, so this angle they didn't tell me. It's tempting to conclude that it's 90, but it's not. So how will I do this then? I think I will have to take the whole one. I think we figured that up upstairs, right? QABO. Yeah, QABO, which is the entire shape. And if you, that's consisting of COB plus QCA plus ABC. Yeah, okay, I got it. So we already did all this, so we just have to plug it in. This one is 84 according to part A. This one is 6p. And this one is 12 minus p, I believe. Yes. And then ABC, wait, hold on. ABC, they told us, is 27. Okay. Okay, I got it. We're trying to find the value of p. All right, well, that's pretty straightforward then. Well, let's see here. 84 minus 27 is what? 47, I believe. And then we have to subtract 12, so 35. Or hold on, let me make sure I get my numbers correct. The numbers are going to be, this will be just 5p, and this is going to be 45. Yeah. Got to learn how to add and subtract here. So then when I divide through, it just gives me 9. And that's pretty much all they wanted. P is equal to 9. Number 3, solve the following system of equations. All right. Well, if I add these guys, I will get 2x, the y's cancel, and that becomes 52, and therefore x is 26. And then I substitute 26 back into one of these guys, so it'll be 26 plus y is equal to 42, so that means y would be 16. So therefore xy is 26 and 16. Okay. Part B, suppose that p is an even integer and that q is odd. Explain why this system of equations has no positive integer solutions. So p is an even integer. So let's move this up a bit. I think I'm going to need a little bit of space. P is even, so that means if we write that, I think that should be good enough. There's a couple ways of doing this. I'll do it both ways, and then you guys can decide which one you like better. So what I'm going to do in the first way is sort of talk about p in terms of an even integer, because all even numbers are even integers are of the form 2 times something. And then I'm going to do the same thing for q, but q they're saying is odd, right? Yeah, so that'll be 2n plus 1. All odd numbers are of that form. And then now we try to solve it, so we're going to add this with this. So that'll give me 2x because the y's cancel and have 2m plus 2n plus 1. Yeah. So the first way is to kind of look at this and say this is 2m plus n plus 1. This is even and this is odd. So obviously you can't have that, right? That doesn't make any sense. So this is not possible. The other way is sort of just to immediately just talk about P and Q without introducing all this M and N stuff, and then just add them. And when you add them, you get 2x is equal to P plus Q. Now 2x, that's an even number. Regardless of what x is, 2 times something is always going to be even. This is P plus Q. P is even, and Q is odd. And when you take an even and add it to an odd, you get an odd. Right? You can try it. Like if the even number, let's say, was 4 and the odd number was 5, that would be 9, and 9 is odd. So obviously even is not equal to odd. So regardless, I mean, they're very similar, both ways of trying to explain that when you try to get a solution, you'll get this equation that even equals odd, and obviously that's not possible. So that's basically, I think, what they're trying you to show. And then now we have this one. Explain or determine all pairs of positive integers that satisfy x squared minus y squared is 420. X squared minus y squared is 420. All right. And keep in mind that x and y are positive integers. So that's important. So the first thing I thought was, okay, is factor this out. And then let's see where we go from here. So we have this times this is 420. So I think we're going to have to make a table here. X minus y, x plus y. And then the product is always going to be 420. X minus y times x plus y. And then we can always figure out x and y. So like this. So this is sort of how we're going to approach this. These are all 420s. So, because that's the end result. Okay, so we have to figure out because they're all integers, this is going to be greater than. I just want to put that symbol in to ensure that you know that x plus y has to be greater than x minus y, since x and y are positive integers. All right, so now what we can deduce is what two numbers multiplied together give 420. There's a lot of combinations here. All right, 420 is what? 2 times 2 times 3 times 5 times 7, right? So that's 2 to the power of 2 times 3 to the power of 1 times 5 to the power of 1 times 7 to the power of 1. So that's going to be 3 times 2 times 2 times 2 factors, which is what? 6 times 4. 24 factors? Wow, that's a lot. So they're making me work here. All right, now let's see what I can get. 420 and 1. 210 and 2, 140 and 3. Oh boy, 105 and 4, 84 and 5, 70 and 6, 60 and 7, 42 and 10, 35 and 12, 30 and 14, 28 and 15, 21 and 20, and after that you stop because we have to maintain that condition that x plus y is greater than x minus y. All right, so now for each of these, like this one, for example, on the side, I have to now calculate this whole thing. So let's do the first one. Let's see what we get. 420 and 1. So if I add these, I get 2x is equal to 421, and x would be 210.5. Okay, that doesn't work because remember they're all both integers. So this doesn't give me any solution, any integer solution. So, I got to go through every single one of these. Oh boy. But I immediately recognize is when you're adding them, the sum's got to be even in order for x to be an integer. So the only ones that will give me an even sum, that one, this one, and this one. All the others would give odd sums, and therefore x would not be an integer. Okay, so that's not so bad. I only got 4 to deal with. So I got to deal with this one, this one, this one, and this one. I think I can do this in my head. It's pretty quick. So 212 divided by 2, that'd be 106. And then you can just sub it into either one of these to figure out what is y. And when you do, that would be 104. So this 76 divided by 238, and then that's going to be 32. This one 52, so 26 and 16. And this one would be 22 and 8. Yeah. And you can do it manually on the side if you can't do it in your head. So these would be the 4 ordered pairs that would satisfy this with the condition that they're both positive integers, x and y. In triangle PQR, T is on the side QR such that QT is 6, TR is 10. Explain why the ratio of the area of PQT to the area of PTR is 3 to 5. All right. Well, this is a very important question because it illustrates a fundamental concept in triangles, and I'll illustrate it by first drawing a little altitude from top to bottom like that. And when I draw that altitude, that is a right angle. Okay. So the right angle is, and I'll call that altitude H. So the area of, say, PQR would be 1/2 base PQ, sorry, we are looking at PQT. Sorry, PQT is what they want us to look at. Okay, I got it. So PQT and PQR. So let's look at PQT then. PQT. That's going to be 1/2 base, which is 6, times height, which is h. Now this question wants you to calculate a ratio, so I will compare it to PTR, and that is 1/2 base, which is 10, times h. And you'll notice that the h's cancel, and this just becomes 3 over 5, which is exactly the ratio that they wanted. So part A leads into part B and part C, because first they wanted you to understand how you can draw that altitude and use it for both triangles, and then get a ratio. And you'll see in part B that you're going to be doing the same kind of thing, but it's a little bit more complicated. All right, so here we go with part B. In triangle ABC, point D is the midpoint of BC, and point E is on AC such that AE to AC, EC is 1 to 2, and F is on AD such that AF to FD is 3 to 1. The area of DEF is 17 to determine the area of ABC. All right, so hopefully I can do this without too much confusion on the same diagram. I'll try. Hopefully the diagram doesn't get too messy. So I'm first going to draw some altitudes first. I'll draw that altitude, and then a couple more, I think. Let's see which one is next. I think this one here, the altitude from D, and these are supposed to be right angles, so hopefully they look like right angles. And then one last one from A down to the bottom like that. So these are supposed to be altitudes, and let's just draw in, well, hopefully they are looking like right angles. If they're not, sorry about that, but those red lines represent altitudes. So just call them H, H, big H, whatever. Okay, so now let's carefully do this. First, let's look at one ratio, which is triangle AEF over triangle DEF. And before I do that, I need to take into consideration this information that they've given me. Since D is the midpoint, BD I will call Z, and DC I will call Z, since D is the midpoint of BC. E is the ratio 1 to 2, so AE I will call X, and then E to C I will call 2X. And then AF to FD is 3 to 1, so AF I will call, I'm probably going to have to use a slightly different color. AF I will call 3Y, and F I will call Y. FD, sorry. Yeah, FD. Okay, so now we can use the formula. So 1/2 base times height for triangle AEF. AEF, so 1/2 base is going to be 3Y, and the height is H. And then DEF, 1/2 base, the base is Y, and the height is also H. So this immediately becomes just 3 over 1. But DEF, they told me is 17. So on this side, I can put a 17. That's AEF. And therefore, AEF is equal to 3 times 17, which is 51. So AEF is 51. So that's very helpful. 51. Okay. So I hope you're getting the hang of what we're doing here. So I'm going to do the exact same thing this time, but on a couple different triangles. I'm going to do it now on the following triangles: AED and EDC. Like that. So AED, 1/2 base, I'm going to use X, and then the height H. And then EDC, the base will be 2X, and the height is H again. So this becomes just 1/2, I believe. Yeah. And then AED is equal to 51 for the AEF part and 17 for the DEF part. And then EDC is what we don't know. And then when you do this math, you get EDC equal to 51 plus 17, which is 68, then times 2, which is 136. So as you can see, we're getting some progress here. And then finally, I guess I have to do it down here. I don't have any space left. The final comparison will be triangle ABD, and triangle ADC. The big ones, ABD and ADC. So the top one is 1/2 base, which is Z times height. The bottom is 1/2 base, which is Z times height. And this basically is a 1-to-1 ratio. Now triangle ABD, not really sure anything about that, so I'll leave that alone. But ADC, we know all of those. That's going to be EDC, yeah, which is 136, plus DEF, which is 17, plus AEF, which is 51. Yeah, this guy is those ones. So that means ABD, when you cross multiply, is the sum of that, which is 204. And then now finally, the ABC is ABD plus ADC. Now, ABC, we just, hold on, wait a second. Sorry, this should have been a D, ABD. Sorry about that, ABD. So ABD is 204, and ADC is AEF. Did we calculate that somewhere? ADC? Yeah, we calculated it here. And that was 204. Okay, I knew we had done it. So there you go, 408. Yeah. So hopefully that wasn't too bad. I mean, it's really just part A. The concept of part A just used several times over and over again. So. And now finally we get to the last one. In the diagram, X, Y, and Z are on the sides of triangle UVW. As shown, line segments UY, VZ, and WX intersect at P. Point Y is on VW such that VY to YW is 4 to 3. If triangle PYW has an area of 30 and triangle PZW has an area of 35, determine the area of UXP. So let's first label what we have in this diagram in terms of what they gave us. So this is 30 here. This PYW, PZW is 35, and I think that's all they tell us. So the other ones I'll label, this triangle I'll call B, A, B, C, D, I guess. Just like that. And then they told me that there's only one ratio in here, right? This guy right here. So that's VY to YW, so 4x for VY and 3x for YW. And I think that's it. So what do they want? UXP. So in my diagram, UXP is labeled as A. So find A, I guess, is my ultimate goal in this question. All right, so off we go. So first comparison, UVY to UYW. So that would be 1/2 base as 4x, and the height, I'm not going to draw in the heights. Well, I could. Oh, whatever. Let's do it. I just don't want to make the diagram too messy, but it should be okay. Yeah, it should be okay. It shouldn't make it too messy. That's the altitude. And I think one more altitude would be sufficient. And I think that's the little guy right down there. Yeah, that altitude coming down from P. Okay, good. That's good enough. Okay, let's go back to the question. So 1/2 base times height, and that height, we'll just call it H, big H, whatever. So then the UYW triangle, UYW is 1/2 base 3x this time times H. So this just becomes 4/3. Yeah. Now I want to use my letters. So UVY is A plus C plus D. And UYW is B plus the 35 plus the 30. So that's B plus 65. And that's 4/3. And if I cross multiply, I get 3A plus 3C plus 3D is equal to 4B plus 260, I believe. Yeah, 260. And I think that's about as far as we can go for now. And hopefully we will come back to this a little bit later. Yeah, when we have more information. Okay, so let's go and do another comparison. This time I'm going to try VPY to PYW. VPY to PYW, the little guys. So it's 1/2. We're using the green altitude this time. I guess we can just put that as, well, whatever color you want, really. It doesn't really matter. So that's going to be like that. So 1/2 height times base, which is going to be 4x, and then 1/2 height times base, which is 3x. So this again becomes 4/3 this time. And the VPY is just D, and then the PYW is 30. Okay, so this is very helpful because this gives me that D is equal to 40. Okay, that's great. That at least I got one letter solved. So I can put that back into here. And when I do, I get 3A plus 3C is equal to 3D, which is 120, equals 4B plus 260. So that means 3 times A plus 3 times D is equal to 4B plus 140. Yeah. Okay, so that's pretty good. But I think I still have a little bit more work to do. Well, let's just keep going here. The next part, let's see, what do I want to do for the next part? I will compare UXW to XVW. And UXW to XVW has the same sort of comparison as A to C. Yeah. 1/2 base times height to 1/2 base times height. Yeah. So that would mean, so when I plug in the values for the two triangles using my lettering, UXV, or UXW I should say, is A plus B plus 35. And XVW is C plus D plus 30. And that's A over C. And let's see, how far can I go here? I can cross multiply, and I get A plus B plus 35 times C. And here I get A times C plus A times D plus 30A. Yeah. Okay. Let's see where this is headed. All right, let's expand this. We have AC plus BC plus 35C. Okay, the AC's cancel. And then D, I think I figured out was 40. So this becomes 40A. And this is 30A. All right, so we're getting somewhere. These cancel. So then we just get left with BC plus 35C is equal to 70A. Right. Okay. And, I think that's about as far as I can go there. So we'll keep that for now. Let's label these. I'm getting a bunch of these, so let's label these. This one I will call 1, this equation. And this one that I just found, will call 2. And hopefully, we'll get something soon. Yeah. Okay. So now let's see what I think. There should be one final comparison, that is VZW to VZU. And if you look back at the diagram, VZW is going to be 65 plus D. And VZU is A plus B plus C. And those should have the exact same ratio as the smaller triangles B and 35, where this is 35 and this is B. Yeah. Okay, so I think we're pretty close to the finish line. I think this is the last one, the last comparison. So this, if I expand this, it would give me, well, D is 40, right? We got that from here, so I can put that. So that's 105, and this is 35, and this is A plus B plus C, and this is B. So that's going to be a 3-to-1 ratio. So that's going to be 3 over 1 is equal to A plus B plus C over B. And if I cross multiply, I get 3B is equal to A plus B plus C. And that means 2B is equal to A plus C. All right, great, finally. And this I will call equation 3. Okay, so I think we are now down to the nitty-gritty here. So the first thing I need to do in order to solve this is sub 3 into 1. So this 3 that I got, I'll sub it into this 1. So since 2B is equal to A plus C, 1 is actually 3 times A plus, hold on, I think this should have been, sorry about that, this should have been 3C. Yeah, sorry about that. Well, at least I caught it. So that's 3C, so this is going to be 3A plus C, and that's going to be 4B plus 140. So A plus C is equal to 2B, so this is 3 times 2B is equal to 4B plus 140, and therefore that becomes 6B. If you subtract 4B, you get 2B is 140, so therefore B is equal to 70. Great. All right, so we got something. We got B equals to 70, and I think now we can just do one final substitution, and I'll try to squeeze it in here since I'm running out of space. We sub this B equal to 70 finding that I just got into where? Into this one, into 2. So that's going to be, let's see here. That's going to give me 70C plus 35C is 70A. So that's 105C is 70A. So that means C is equal to 2 over 3A. Okay, and then one final substitution into this guy, sub into 3. And so we have 2B, which is, B is 70 from here. So that's 140 is equal to A plus C. And C is 2 over 3A. So this would be 5 over 3A is equal to 140. And therefore A would be 84. There we go, finally. And 84, which is A, is what I needed because I used A to represent this triangle UXP. So there you go, finally.